So continuing our lecture, kinematics in two dimension focuses on projectile motion. So projectile motion. Projectile is the name given to a body thrown with some velocity at an angle with horizontal and then allowed to move under the action of gravity alone without any external force being applied to it. So the path followed by the projectile is known as its trajectory. So one of the example is stone thrown at a given angle. So let's say this is the horizontal ground and a stone is thrown from this point at a certain angle. Okay, let's say angle theta. Then say this thrown at a certain angle and reaches its maximum or highest peak, then starts to descend, going back to the ground. Okay, so this is called the trajectory. Now projectile moves under the effect of two velocities, so uniform velocity along horizontal, so that is the velocity along the horizontal is always given and it doesn't change. Okay, so no change in the horizontal velocity. So a uniformly changing velocity, either increasing or decreasing in the vertical direction due to gravity. So that is the motion taking place along the horizontal as well as in the vertical direction. So like for example, you have a trajectory. Given example, a ball is thrown at a certain angle. So that is this velocity has its horizontal component and vertical component. So the horizontal component of the velocity is always uniform all throughout the trajectory until before reaching ground, while the vertical component of the velocity decreases while the object is moving up until reaching its highest possible height, and then the horizontal velocity becomes zero. Then vertical component is then increasing from that point. Okay, then study of our motion will be friction, air resistance is neglected. So the effect of rotation of Earth and curvature of Earth is negligible, and acceleration due to gravity remains constant. It does not change with height. So projectile given angular projection. So let us consider this projectile motion. This is its trajectory. So let's say initial velocity. So when we talk about velocity, it is in vectoring quantity. It has its magnitude and direction. Okay, so initial velocity has two components, the horizontal and vertical component. So let's say this is v of I x, and this is its vertical component v of I y. So when computing or solving for initial velocity or horizontal component of the initial velocity, you have this formula. So that is initial velocity multiplied by cosine theta, and the vertical component of the initial velocity is given initial velocity multiplied by sine theta. So these are the two formulas for computing the x and y component of the velocity. So let us consider now point A and at any point along the trajectory, let's say point P. Now at point P, the velocity becomes velocity v. Okay, from initial velocity vi, at any point after a certain given time, velocity changes to velocity v. Okay, velocity v has now components v of x and v of y. Let us first consider uh, x components using uh, final velocity is equivalent to initial velocity plus acceleration multiplied by time. Okay, so the final velocity, if we are considering point A, initial position, and let's say point P stands for the final position. So that is final velocity is given as v, and initial velocity is v of I x. We are considering x components. Okay, then plus acceleration along x and time t. Okay, so simplifying the equation, we will get this one. Why? Because acceleration along the x is always 0. So ax is always, acceleration along the x is always considered 0. Okay, so when solving velocity at any point given time, velocity, like horizontal component of the velocity initial does not change at any given point of time along the trajectory. Okay, now similarly, let us use same formula, v of f final initial, then uh, acceleration and time. Let us consider now the vertical component. So vertical component, considering point A and point B. So point P, final velocity is given v. So the vertical component is v of y. V of y will be equal to initial velocity of the y component, then acceleration along y is always given as negative g, negative acceleration due to gravity multiplied by time, and v of y based on this given figure, angle b, so that is v of sine beta will be equal to v of iy. From the previous discussion, this is v of I sine theta minus acceleration due to gravity and time. So this is applicable. Okay. Similarly with this one. Okay. But then we are going to use this one and this one. So path of projectile is known as its trajectory. It is the equation of a parabola. So hence the path of a projectile is parabolic. Okay. So the path of the projectile is the parabolic curve is 1. Okay. Now x and y components. So that is, let's say, consider again point A and point B at any given time. So let's say if you want point P is right here, that is also good, but then provided given time. So let's say x component or x distance is up to this point. Okay, so solving for that distance, we use this formula. Okay, and the y component, this one. Okay, y component, you can use this formula or this formula, depends on the given. Like for example, y component or y distance, vertical distance. So given the distance, horizontal distance, tangent given angle theta minus acceleration due to gravity, this is constant, x is given, okay, and initial velocity cosine theta squared, okay, or this one, uh, x distance and then tangent alpha is given here, okay, provided the range is given. Range is from starting point up to the body hits the ground, so that is this displacement, and it is called range. Okay, so time of flight. When we see time of flight, it is the time for which the object remains in flight or in air. So time of flight consists of two parts. So first part is from A to point B, known as time of ascent. So let it be T1. So that is from point A to point D. Okay, so this is called the time of ascent. And from D to B, so from point D to point B, and this is called time of descent, which is T2. So it is found that time of ascent is equal to time of descent. So T1 is equal to T2. So solving for the time of flight, you can use this formula or this one. They are just the same. Like for example, V's of y. V's of y is simply y component. So that is V's of I sine theta. So this should be V's of I y. So 2 V's of I y all over g. So 2 initial velocity sine theta all over g. So horizontal range, as I have said earlier, is this displacement from initial position to final position, or when it reaches the ground by hitting. So this is the range, okay, from this point up to that point. You can solve range by using the three formulas given. Choose only one depending on the given. Okay, so that is initial velocity should be given for this formula. It's angle, initial velocity, angle, and okay, initial velocity and angle. Okay, and uh, this is x component of the initial velocity, and this is the y component of the initial velocity, and that is multiplied by 2. This is are just similar. Okay, and then initial velocity square, mm, sine 2 theta. These are derived formula from this one, similar to this. Sine 2 theta, recall your trigonometry. Sine 2 theta is equivalent to 2 sine theta cosine theta. If you are going to simplify this equation or this formula, 2 sine theta cosine theta, okay, then b of I, kaya b of I squared sine 2 theta. Okay, so maximum horizontal range. So the maximum horizontal range is given with this formula. So our max is equivalent to initial velocity squared over acceleration due to gravity. So when the range is maximum, the height reached by the projectile can be solved using this formula. Sometimes, if R max is already given, you can use the last formula. So that is h will be equal to maximum range all over 4. Okay, or you can choose depending on the given. Okay, so illustration 2.1. A batsman kicks a ball at an angle of 30 degrees, speed of 30 meters per second. So assume that the ball travels in a vertical plane. So calculate the time at which the ball, this is ball, reaches the highest point. So we change that. That is a ball. Okay. The maximum height reached, the horizontal range of the ball, and the time for which the ball is in the air. So let us draw a figure. So let's say this is a horizontal plane, and then a batsman kicks the ball at an angle of 30 degrees with initial velocity of 30 meter per second. Okay. Oops. So this is the rejected. Okay. Reaching its highest point. Let's say highest point is at this point. Then begins to descend, hitting the ground. Okay. Now, what calculate the time which the ball reaches the highest point? So the time of ascent. Okay. Recall that time of ascent is equivalent to time of descent, which is equivalent to the time of flight all over 2. So time of flight is the ball or the particle or body is in flight or is in the air. So the formula for this one is gives you uh, initial velocity, then sine theta all over 2, all over g. I mean acceleration due to gravity. So initial velocity is given 30, then sine 30 degrees, then divided by 9.81. So this gives you an answer of 1.53 seconds. So this is time reaching the highest point. So that's number 1. Now, number 2, calculate the maximum height reached. So maximum height reached will be this one. Okay. So formula for maximum height reach, let's say that is h max, maximum point will be equal to square of the initial velocity and sine squared theta over acceleration due to gravity. So that is twice the acceleration due to gravity. So this will give you initial is 30 meters per second, that is square, then sine squared 30 degrees all over twice the acceleration due to gravity, which is 9.81. So you get the maximum height, uh, 11.47 meters. So that is the maximum height reached by the ball. Now, for the third question, calculate the horizontal range of the ball. Horizontal range is from initial position up to the ball hits the ground. So this is range. Range R. Solving for the range. So range will be equal to initial velocity squared, then sine 2 theta over acceleration due to gravity. Okay, so initial velocity is 30, so that will give you 30 square, and then sine 2 theta is 30 degrees. Okay, and then 9.81. So when computing or calculating this value, you need to simplify first the angle. So 2 times 30 is 60, so that is sine 60 degrees. 30 squared multiplied by sine 60 degrees divided by 9.81 gives you an answer of 79.45 meters. So for number 4, okay, so number 4. Number 4, time for which the ball is in the air. So that is time of ascent plus time of descent. So you have already computed the value of time of ascent. You can multiply by that 2, or simply you can use the formula uh, twice initial velocity sine theta over g. So this will give you 2 multiplied by 30, then sine 30 degrees. 30 degrees over 9.81. So this gives you an answer of around 3.06 seconds. So 3.06 seconds. Now let us consider illustration problem 2.2. So a footballer kicks the football to check his stamina with velocity of 60 squared of 2 meters per second at an angle of 45 degrees. Find the following after 3 seconds. So the velocity of the football after 3 seconds, angle made by the velocity with the horizontal and vertical displacement. So let's draw the given scenario. So let's say this is the horizontal plane and a footballer kicks the ball 45 degrees. Okay, 45 degrees with velocity which is equivalent to 60 square root of 2 meter per second. So then, so calculating after all 3 seconds. So let's say 1, 2, 3, 4, 5, 1 to 3 seconds. Let's say it is on this point at time was 3 seconds. Okay, now at time 3 seconds, so there should be a, what call this, velocity at that point, and this velocity has its horizontal and vertical components, piece of y, okay, and it has an angle at the given point, angle theta. So velocity of the football after 3 seconds, so this is 1. Angle made by the velocity with the horizontal after 3 seconds, theta, that is 2. And the horizontal and vertical displacement, so that is the horizontal displacement will be from initial position up to this point, so that is the horizontal displacement of x, and the vertical displacement, which is y. Those are the unknown after 3 seconds. So let us first solve the velocity of the ball. So velocity of the ball will be computed as how? So in order for us to solve the velocity, we need to first solve the components x and y. Okay, how are you going to solve that? So we need first to solve the horizontal and vertical component of the initial velocity. So v of I y and v of I x. Okay, so for number 1, solution. So initial velocity of x will be equal to initial velocity multiplied by cosine theta, and initial velocity of the vertical component is v of I sine theta. So this is equivalent to 60 square root of 2 meter per second, that is the initial velocity, and then cosine of 45 degrees. Cosine 45 degrees is 1 all over square root of 2, so this becomes 60 meters per second. Okay, now v sine, okay, 60 square root of 2 initial velocity, and then sine of 45 degrees. So similar answer, meter per second square, meter per second. So that is after 3 seconds. So let's say after 3 seconds. Okay, so vertical component Vy after 3 seconds, so V of y will be equal to initial velocity y, then minus acceleration due to gravity multiplied by time. So this will give you initial velocity of 60, 60, and then minus 9.81 multiplied by 3 seconds. So this is the vertical component after 3 seconds, the velocity v. So the answer would be 30.57 meter per second. Okay, now the horizontal component x If you're going to apply vis of iy will be equal plus acceleration along x multiplied by time. Acceleration along x is always what? 0. So there's no, I mean this is x. Sorry. So that is x. X is of ix. X component. So acceleration along x is 0. So vis of ix is equivalent to velocity of the x component after 3 seconds. And recall that uh, we have said that the horizontal component of the velocity is uniform all throughout, right? So therefore, vis of x will be equal to 60 meter per second. Now you have the x and y components of v. So solving for the velocity, so we can use Pythagorean theorem. So that is vis of x squared plus vis of y squared. So substituting all the values, so that will give you uh, vis of x is 60 squared plus 30.57 squared. So the velocity after 3 seconds will be 67.34 meter per second. So this is the answer for number 1. Okay, now for number 2. Angle made by the velocity with the horizontal after 3 seconds, so that is angle theta. We can solve that by using this formula. Oops. Say this. Oops. Okay, I'll just erase this one. So you can use this formula for number 2. Angle made. So that is tangent theta will be equal to y component all over x component. So in trigonometry, tangent of an angle is always given as opposite all over adjacent. Okay, so that is y all over x. So by solving for the angle, that will give you theta is equivalent to arctan of by, which is 30.57 all over 60. And the answer is 26.99 degrees. So this is the angle made by the velocity with the horizontal. That is the angle theta. Okay, so that is 26.99 degrees, or approximately 27 degrees. Velocity after 3 seconds is this one. Now for number 2, horizontal and vertical displacement. So horizontal x and y displacement. Okay, So see, okay. So this let us just draw then projection 3 seconds. Okay, then this is the initial and that is the final at after 3 seconds. So this is the y vertical displacement and this is the horizontal displacement x. So horizontal displacement x, shortest distance. So we have uniform horizontal velocity. So if we say that x will be equal to uh, initial velocity multiplied by time, or simply using the formula S is equivalent to initial velocity time minus one half, oh, mean plus one half acceleration times squared. So referring to the all the x component, so horizontal displacement will be equal to initial velocity x multiplied by time plus one half acceleration along x then time squared. Then we always say that acceleration along x is always equal to 0. So x component or x horizontal displacement will be equal to v sub pi x multiplied by time, which is equivalent to 60 meter per second multiplied by 3. So this is equivalent to 180 meters. Okay, now that is the horizontal displacement. Now for y, applying similar formula, but then this is negative g, so we will have negative 1 half gt squared. Okay, so that becomes v sub I y, all the y components. Okay, v sub I y, then multiply by time minus 1 half 1 half acceleration due to gravity time squared. So this is equivalent to v of Iy is 60 Iy Biy, let us double check. Biy, there it is 60. Okay, so 60 multiplied by 3 minus 1 half, and this is 9.81. Then time is 3 squared. So that is y will be equal to 135.86 meters. So these are the two answers for number 3. Horizontal displacement is 180 meters and the vertical displacement is 135.86 meters. So in solving projectile motion, you simply uh, refer to the x components alone, then y components alone. Okay, so for example, this one, uh, x component, so v sub I x t, so that is this is the v sub I x. Okay, and acceleration of the body or the ball or football is always considered 0 for x, and for y we use acceleration as negative 9.81. Okay,